on behalf of ASME AUST Student Chapter is to welcome you all to today's webinar about introducing artificial intelligence to the non-computer based audience. We feel honored to have with us the Honorable Chief Guest, His Excellency MD Ruisuddin Khan, Professor in the Department of Mechatronics Engineering at International Islamic University Malaysia. Sir, though you hardly need any introduction, but I would like to share some of your activities and achievements to our listeners. Sir received his BSc in Mechanical Engineering from RUET and MSc and PhD from BUET. He has been serving more than 20 years in the Mechatronics Engineering Department of IIUM. In IIUM, he has been coordinator of Autonomous Systems and Robotics Research Unit, a member of the Executive Committee of IEEE Robotics Automation Society Malaysia chapter. And most amazingly, Sir has numerous scientific articles published in different international journals and conferences. You have made all of us proud of your distinguished work in numerous capacities. And guest of honor, our Professor Dr. Mazharul Islam Sir, Department Head of Mechanical and Production Engineering. We need not to say about Mazhar Sir. The whole campus know he is the man of distinct vision and fountainhead of ethics, morality, and illuminating ideas, and idol of knowledge and experience and inspiration to all of us. Well, so artificial intelligence has evolved as a promising discipline during the last few decades, especially in recent times, thanks to ChatGPT developed by OpenAI. AI is now hotcake in these days. People with computer science background are playing a key role in AI, but as a non-CS background audience, we are now more eager to know about artificial intelligence, how it works, does it make us unemployed or something else? And finally, the wait is over. Now I would like to request Professor MD Ruisuddin Khan sir to share some knowledge and experience on artificial intelligence to the non-computer based audience. Sir, please.
Okay, thank you for a generous introduction. So let me try to share, because I also forgot this how to do. So different platform. We are using Microsoft Teams here. Now when it comes to Zoom, we started Zoom at the beginning, but later on we forgot. Okay. Screen. Is the share working?
Yes, sir. Yes, sir.
Okay, assalamu alaikum warahmatullahi wabarakatuh, and very good evening. So this is the topic I selected based on my what I know about artificial intelligence. Interestingly, I'm not an artificial intelligence guy, because now we are inside artificial intelligence, so we have to know some artificial intelligence, and you have to do some artificial intelligence. Specifically, it is for the new generation. We are the generation going to retire soon, so we have to tell you what is ahead and what you need to do. So the presentation outline of my topic is Introduction, Artificial Intelligence, Fuzzy Logic, Artificial Neural Network. So I was supposed to cover more, but because of time constraint and so many things, I could not make it. And interestingly, I am not actually an artificial intelligence guy, as I told. Okay, so this is what is I'm sharing. Mostly these are the some what is called slides from my colleagues, my students, and some are from the books. Okay, so let's first see what is the scenario of artificial intelligence. This is the hype cycle for artificial intelligence 2021. So if we look at this, just hold on. I'm trying to find pointer. Where is the pointer? Okay, so here, if you look at this block here, so this block has the color blue, and if you go down, we see this is the hype cycle for artificial intelligence 2021, and we are just at the beginning of 2023. So within the next 2 to 5 years, so these are going to be the AI stuff. Okay, you can see there are these are blue, and here at the top there are AI. So AI is the next generation technology. So we cannot get rid of AI. And if you look at the application of AI, autonomous mobile robots, we are now hearing about the autonomous cars, the smart robots, those robots, whatever we are now planning is no more deterministic. So they have the decision-making capabilities. Deep neural network and deep learning. This is the recent AIs and the IoT platform. And the new kind of robots are also coming into the market: exoskeleton, flying autonomous vehicle, autonomous driving, and 3D printing. Oh, sorry, just hold on. Yes. I'm in a meeting. Sorry for the disturbance. Okay, so this is the scenario of artificial intelligence. Now, if you go to the definition of artificial intelligence, what is artificial intelligence? And in the first place, what is intelligence? Intelligence definition: ability to understand and learn things, ability to think and understand instead of doing things by instinct or automatical. So it has a thinking element. That means we can do it, make the decision, and then we can do it later. Okay, so it has this element present. So we can say what artificial intelligence tells about the ability, able to think and reason, apply knowledge, know things it knows and does not know, solve problems, generate new ideas, generate new knowledge. Artificial intelligence is a branch of science that deals with the machine to find solutions to complex problems more like humans. This generally involves borrowing characteristics of human intelligence and applying them as algorithms in computers. So computer and algorithm, these are the two keywords that actually play vital roles. And if you go to the different domains of artificial intelligence, it's quite the big number. So here some are just listed: expert system, logical reasoning, knowledge-based system, fuzzy logic, artificial neural network, and evolutionary computing. So the last three are the current trend, specifically artificial neural network and evolutionary computing. So these are the current trend in artificial intelligence. So if we talk about the knowledge-based system, what is a knowledge-based system? A system that is built around a knowledge base that is a collection of knowledge taken from a human and stored in such a way that the system can reason with it. And what is knowledge? Knowledge is the sort of information that people use to solve problems. Knowledge includes facts, concepts, procedures, models, heuristics, examples. So whatever we are learning, it's the element we are actually achieving out of it. Those are basically knowledge. knowledge may be specific or general, exact or fuzzy, procedural or declarative. So here comes the element. Knowledge can be specific. So when we talk about this traditional science, physics, chemistry, so in most of the cases, they are very deterministic and very specific. But the way we work in the universe, there are some issues where things are very fuzzy. That is, we cannot say exactly this or exactly that. That is called the fuzziness. Okay, so in autonomous robotics, basically, while we talk about the autonomous robotics, one of the important issue regarding autonomous robotics is they call SLAM, simultaneous localization and mapping. And localization is a fuzzy process. You cannot put the robot exactly the point you are interested. Okay, so you have to go with stochastic information, then you can come up with the level of exactness. You cannot say what is exact location. So here comes the fuzzy issues. And expert system is one of the elements which is actually used in the fuzzy reasoning. And as we mentioned, what is expert system? So expert system is basically the knowledge of a particular domain. So when you talk about the doctors, it's a eye specialist. So eye specialist has got expertise regarding eyes. So he can tell what causes what kind of problem. So this is the cause-effect relation you can put in a database. That is basically the knowledge base. So once you have the knowledge base available and you can retrieve it through a system, that actually is an expert system, and that actually works quite well for many applications. So these are the early artificial intelligence systems. And artificial intelligence has got applications everywhere. So here you can see instrument landing system, automatic pilot, planetary rovers, collision avoidance systems, specifically in case of the autonomous vehicles, anti-lock brake, smart airbag, intelligent road vehicles, smart highways, and so on. Now, after this introduction of this intelligence and intelligence systems, so I'm just going to the fuzzy logic systems. So what is a fuzzy set and what is a crisp set? When we talk about our data set, we actually classify the data in the traditional way called the Boolean logic, or what we call the set is a crisp set. We actually give a hard limiter to decide what it is. Okay, I have the next slide where it makes clear. Here you can see this slide 0, 1. So if we are defined before this line, these are all zeros. After this line, these are all ones. But we have situations where we cannot say exactly this is 0 and this is 1. We call the multi-valued logic. In that case, we actually classify with different level. If it is exactly, say, if you look at the color by different people, someone will say, if it is red, someone will say its value is exactly red to him. Some other one will say it's not exactly red, it is little bit less red. So here comes the fuzziness. So how we classify this little bit more, little bit less, this we have to give a membership value. So this is what we are actually giving the multi-valued logic. Instead of defining, so if it does not, if it is not red at all, so it is 0. If it is completely red, this is 1. If we consider it is in between somewhere, it can appear with different membership functions. So here there's a clear example. So when we go to the crisp set, we have a very clear-cut definition. But the problem is, sometimes when you go to this demarcation line, we cannot actually decide, is it really according to the crisp set, it is on this category, on the other category. So here you can see the degree of membership of tall men. So in the crisp set, we define if a person is 180 above taller, so he is considered as tall. If it is less than 180, we call him not tall or short. So here you see we have list of some persons, their heights are there, and of their degree of membership. In the crisp set, you see above 180, 181, 198, 205, 208, all we are telling in the crisp set it is tall. But below 180, we are calling them not tall. That is maybe short. Okay. So you see, if it is someone is 79.99, still we call him short. That is in the crisp set. But in true sense, he's more or less tall. So that is where actually fuzzy logic comes in. So now you see the fuzzy set, how we are defining this membership. So 180 and up, we are giving the membership values. So membership value, basically we start with 0 and give maximum as 1. It's the membership values, the way we define it looks like the probability, but it is not probability. Okay. So here we can see 180 up, we are putting the membership value 0.82, 0.98. Then from 205, we are telling exactly 111. That is exactly top. But if it's 198, okay, he's very close to tall. Then 181 is tall. Then lower than that, we are actually decreasing. You can see here 0.78. If you say 0.78, where in the crisp set we mention 180 as tall, and when you are mentioning 179 as 0.78, it makes sense that it is not short basically. So this is what actually the way human understands the word. So fuzzy set representation. So when we have the fuzzy set, like we have the membership function, so how do we represent? So we give the membership value between 0 and 1. So here you have the fuzzy set, its membership is between x 0 and 1. It is not 0 and 1. It is starting from 0 until 1. As we have just shown, this is the fuzzy set, how we define. So this is the way we actually define. And the interpretation of this is, so mu x membership function is equal to 1 if x is totally in A. Mu x is equal to 0 if x is not in A. And mu s in between 0 and 1 if x is partially in A. That is when we define a set. So how we consider the set? Inside the set, we have numbers, as we have just shown the numbers before. So these numbers starting from one value, say 150, 160, 170, 81, like this. So these are the set A. And inside the set, we are actually defining some class. And when we define the class, we don't define like using the crisp set. So like 180 and up is tall, and below 180, everything is short. Not like this. We give a plus membership value. If it is very close to 180, either on the higher side or the lower side, very close, we give say a value point or something. And this is where actually comes the human knowledge. So how we define this membership function, it is experience. And this is basically comes from the expert system as well. So expert system is very important also for the fuzzy logic applications. If you don't have the proper expert system, then you have to build an expert system to have the fuzzy rules. Okay, here you can see the representation, the graphical representation of the fuzzy set. So we classified in the crisp set, up is there, short, average, top. So here you can see if it is someone is within, someone has the height between 150, 170, we declare them as short. If between 170 and 180, we declare as average. If more than 180, we call that tall. So that is the Scripps declaration. And if you call the membership function, all has got the membership function, one in their corresponding domain. In between, we have the scale, but those are not the values. But when we do the fuzzy reasoning or fuzzy, what is called membership function, so the same one we declare this way. So this is in our control. So this is not that it is very rigid, but even with this control, it gives significant good results for many applications. Okay, and in some of the cases, actually, we cannot have the exact values as well. So that is one of the domain where the fuzzy logic works very well. So here you can see the way we are defining the short. So below 160, membership function 160, the membership is gradually decreasing. And when it goes to 170, we say it is average. And when we declare average, we start, say, maybe from here, we can see we started from 165. And then we finished at 185. So these are the heights, and exactly one is at 175. And then we have the top. So the up is the crisp set and down is the fuzzy set. And there are ways of the representation of the fuzzy set. So you can see the fuzzy set the way we represent. So here, if you consider the x1 mu a, so x1 is the value and mu a is the membership. Okay, so this is one way of representation. You put the what is called value of the function, and then we classify according to its membership. Okay, so here you can see we are giving the membership x1 as the membership a, and x1 this is membership, x2 this is membership, xn. And the membership, as we mentioned, their value lies between 0 and 1. And there is another way of representation. This is the same thing, mu a divided by x1. So this is not a division, this is a representation. Okay? In fuzzy set, there are some confusing issues. Some of the confusion I didn't put here, because in some of the cases, they actually put this plus this plus this. So that looks like an algebra, but that is not algebra. That addition, you are not allowed to do the addition. Similarly, this is the mu a is the what you call membership function, and x1 is the value. So this is the way we have. So here you can see the same as a declaration in the way we represent in the second category. So tall man 0, 180. That means the membership function is 0 and height is 180. That means when 180, his membership as tall is 0. That means it's not considered as tall. He must be more than 180. Then 185.5. So here, if you look at this, so here in this diagram, you can see 180. So we put at 0. Then 185. So it is here, we put 0.5. Then 190, we put 1. So this is the tall man. The other way, we just give the bounding line, the extreme two positions. So here you can see 0, 180 and 190. And here we have actually controls. So how we make this line, there are different techniques. So I'm not going to, because fuzzy itself is a course for maybe half a semester. So fuzzy set of short in a similar way we can define like this. Okay, the short man. So you can see this is a short man here. So when 160, then his membership as a short is 1, because short is, you can see 170 and below until from here you can see. Okay. So this we can consider, this part we can say he is kind of short. But if you consider this part, he is exactly short. And in case of the fuzzy set, also we see another interesting thing. So here there are overlaps. So this is, here we have the fuzziness and this is more fuzzy. Okay, so there are the two sets have got the intersection. So similar way we have the declaration of short, average, and top, like this. Okay, now how we decide out of this fuzziness? Because when we give the input basically are crisp. And when we want to work, that is also crisp. That means you want to make a decision, you are giving some input from two sensors. And this sensor data, whatever it received out of it, say specifically if you are using, say, camera, because of the improper lighting, the same color or same thing, it will display in different way. So that is why just for the camera, if you just tell it is exactly black or it is exactly red, it is actually not wise. So that is why whatever value we get, we have the membership function declaration, we actually get this value, and this is the sensor. So whatever sensor value we give, and we have the declaration beforehand. So we have the declarations beforehand. So we have the membership function just as we have defined before. So A1, A2, A3. So these are the membership functions already defined. And there is another class, B1, and each membership function is also defined. Now we have the inputs. So inputs can be anything. We can give an input in the computer manually, depending upon the way we are working, or maybe it can be a sensor. In most of the cases, when we work, basically inputs are from the sensors. Okay. So if the sensor data comes, sensor data will come exactly as a crisp value. But this crisp value in the fuzzy set, you will find this is actually located at a membership location. Okay, so these are the membership location and these are the membership location. Now we have the fuzzy calculus or algebra, whatever you can say. So this is whether they are intersection or they are union, depending actually we can make the decision. So here you can see, so we are making some decisions. Here, if it is union, so then the logic works is a what is called maximum of OR. So what is the value here? In this case, you check on this data and check on this data. So here you can see this data is the logic is mentioned. What is called the first one A is 0 and second one A is 0.1. Okay, and the logic is OR. So for we have to take the maximum value. So for 0 and 1, the maximum is 1. So here we identify this is the one out of this fuzzy rule. Basically, we have to set a rule base, we call. And rule base basically comes from expert systems. It can have the multiple elements in the rules. So this is the one rule. Second, for A2 and B2, so we can see this is the AND logic. So that is union. So A2, and in case of the AND logic, we have to take the minimum. So we are taking the minimum. So out of this 2 is 0.2. So that's the way out of this fuzzy set, we are making the what is called fuzzy outcomes. But these outcomes is not the final outcome. So once we have all this, actually we can put here. Okay, so basically you can see this is here. This is the part we are showing here. This is the part we are showing here, and this is the part showing here. And if you put together all this together, this is basically what we have the outcome. And this is still fuzzy. And now from this fuzzy, we have to come up with the crisp value. So there are different techniques of actually calculating the crisp value. One of the technique is to calculate the centroid of this area. So centroid of this area, we know from our mathematics, we studied integral calculus, or those are in mechanical engineering, you have studied strength of materials, so we know how to calculate the centroid. But they have the easier way because they don't need to go very precise, because we are dealing with fuzzy sets and we want to make very precise. That is also putting extra burden. So anyway, we can have the centroid calculation. So here you can see at the end, this is the centroid. So this centroid value corresponding to the centroid, what is on the horizontal axis, that is the crisp value. That means we give these two inputs and they were in the fuzzy sets. And the fuzzy sets, we have the expert system. This actually, this if-then logic, they actually came from the expert systems, or they call the fuzzy rule. And how to handle the fuzzy rule? We have the calculations, basically, and or not. These are the logics we actually use. And after these fuzzy inferences, we have the final decision, or we call the defuzzification value. So that means if you are running a system, say you are running your washing machine. So washing machine can have the input. So when you give the input, so what kind of clothings? So okay, the clothings are wool. So wool may be in the soft category. So you put the wool. Then you give the amount of soap. So you give the, this is the amount of soap. Okay. Then what should be the speed correspond or the weight? This is the cloth category, soft, and how much is the weight of the clothing? Because clothing you cannot control. Sometimes you will get 2 kilograms, sometimes you will 5 kilograms, like this. And then when you are running, the water will soak and weight will change. So if you go for the crisp set, it is not actually very logical to operate the system. So we have this fuzzy declaration and we have the inputs already given. Now the machine needs to decide what should be the speed of the machine. So based on the rule base, generally the rule base we set up in the computer, then we can actually make the calculation. And to operate fuzzy logic, there are basically two ways. One way, you can have the computer running and you are running your program and you have the input and you have the output. This is one. Another is the standalone system. Basically, these are the programs you convert to executable files, and then you form a chip, and the chip you actually install in your device. And that chip has got its inputs, which are basically the sensor inputs, and the outputs. Say in case of the washing machine, there are quite a number of outputs you can see. So here we are just showing one output, but it can have multiple output. What will be the speed, and how long it will operate, and what should be the temperature of the water. So it can have multiple outputs, and it will decide the crisp values, and accordingly it will actually direct the corresponding controller to put the input value to the controller system. Okay, so this is one of the system we call the Mamdani style. There is another method is Supinu. They are very similar, but in terms of calculation, that is computation burden is a bit high. Okay, now let me go to artificial neural network. Any question out of the fuzzy? Audience, any question? Or you are fuzzy also? Okay, let me proceed. The artificial neural network, fuzzy inference system and artificial neural network are two of the most prevalent methods for incorporating some kind of intelligence in a system. And what is artificial neural network? So ANN is a collection of networked artificial neurons inspired by the structure of the brain, cerebral cortex used as a data processing system. An artificial neuron is a mathematical model of biological neuron. So if we look at the structure of our neural structure of the brain. So neural structure is more like this. So we have the neural cells, we call the soma. So it has the dendrites, and the dendrites actually receive through the synapse, it receives the input, and then through the axon, it actually communicate to the another soma. So that is basically the neural structure. And here in between you have the processing. So when we have this data and we send it, so we actually process and we come up with a value. And if we look at this structure in artificial neural network, this is basically a learning kind of system. That is, we make the machine to learn something. So what is basically learning? So we have definition later, but let me introduce it here. When we talk about the learning, there are two kinds of learning. One is called supervised learning, another is unsupervised learning. Supervised learning means you are given a thing, you see it is its characteristics is given, you what is called memorize the characteristics, and later on when you see again, you can say, okay, this is this. That means if you see a cat, you look at it, so through our brains actually we extract some characteristics. So next time when you see that cat, maybe it is in a different orientation, and still we can recognize it is a cat. So this is called the supervised learning. So we have to give the characteristics and we have to do the system. So that is the way. Unsupervised means we don't have the output given. So we get the input, and from the input actually you have to learn. So this is basically this kind of learning easily we can understand. So when we are doing the mapping, as I mentioned in the autonomous robotics, we have a term called SLAM, simultaneous localization and mapping. So mapping can be map-based mapping, that is already you have the map, and from that map actually you learn it where to go and where not to go. Another is you don't have the map, you are going there and you have to build a map. So what you do, you go there, you check what is it, whether it is an obstacle or not an obstacle. If you try to proceed, you cannot proceed, you go back and you understand this is not the area where you can go. So you put some value in you. So generally we call the penalty, punishment, and reward. So you are going to move from one point to another point, and in between you have the obstacles. So for unsupervised learning, basically because the obstacle is not detected beforehand, so when you move, you say, okay, this is the direction you cannot move. So you put a penalty mark. That means so whenever you try to move in this direction, you will not move. So that is called the unsupervised learning. Okay, so artificial neural network has been defined before. If you can look at here, a collection of network artificial neurons inspired by the structure of the brain. Okay, so here basically it is a mathematical model, we can say. So what is the mathematical model? In this mathematical model, as we are talking about, the neurons are receiving information through the dendrites. So here we have the information inputs. These are basically the sensors giving the information to the soma or the cell basically. So here actually we make some calculations. And what is the calculation? Depending upon different structure. So at the first place, let us consider we don't know anything. So when we are putting here, we could just sum up these inputs. But we actually try to come up with some characteristics of this input at the output, so that we have an input-output match. So that is actually we call the learning process. So if we say we are to make a learning, like we have a banana as input. So if we say the input of the banana, what is the input? If you capture image of the banana, then this image we do some analysis. We can have the pixel values, is mean, variance, distribution. So some data we can have. So that we have here. And then we have some processing. After processing, we get some set of output here. We put this banana again in different orientation, and we make again this calculation, and we get very similar to the previous one. That means we have already trained this network. That means if we now put any other banana, so it will tell, okay, it is a banana. Like, so this is basically the learning process. Now, what we do in the learning process, basically, without the weight, actually, the learning is not that good. Basically, the learning doesn't occur. So what we have to, the input value is there, and we multiply with the weight. So these are the weights we put here. And these weights, what are these? Okay, let me just, because here, if you want to understand this, you cannot understand that easily. So if we go back to our basic geometry, so you have a set of points available for you. So you have set of points in a coordinate system. Okay, so here points here, points here, here points here, and here points here. So we know that if we have 2 points available in a space, I can derive the equation for a straight line. Okay, y is equal to mx plus c. That means if I just take this point and this point, so we can actually come up with the equation y is equal to mx plus c. So now we have fit at this curve. Now, if we check back with this, what we call, okay. Now, if you put this value in that curve, you find that equation is satisfied. So this is already the point in between, and this is the point outside, and this also satisfied. That is, we have developed a system which can actually predict the other values. If I give any value x, you can calculate the value y. So that is basically we are doing. So this is, we can consider it is a kind of learning, but it's a very deterministic learning because the points are just along a straight line. But if these points are not along straight line, they are very much distributed. So they are here, here, like this. Okay. Then how do we represent these lines? These are the points. And we want to keep track of these points, or we want to predict this point. So we have techniques. We call the regression analysis. We use the regression analysis. So regression analysis will basically fit a curve. If we give a straight line, it will just fit a straight line. So there will be we minimize the errors, and you might have learned this least square curve fitting. That is actually basically we use for this regression analysis. So if you do it, we can actually determine this line. And from there, if you give any point as the input, you can get the output. So that is basically the way we work. Now, when we go to the complex domain, the number of variables is y, they are not of the same nature, then how to fit this in a system? That is basically what the new neural network does. So while you make a curve fit in the what we have, y, sorry, is equal to ax plus b. So basically, when you go to the curve fitting, we actually calculate the value of a and b out of this set. Okay, and here these w's are very similar to a and b, but the difference is here these w's, the weights, we don't know. We have to generate the weights. Generally, we generate the weights using random numbers between plus 0.5 and minus 0.5. We generate the numbers. Then we have the calculation procedure. We are going to show the calculation procedure. Here we have the summation, and sometimes this calculation also doesn't work well. what we have to do, we have another element which we call the bias. We have the bias. Okay, now you can see here. So this is actually the way we are working. So we have the input, we have the weight multiplied, and we have the bias. So we have the sum of it here. Now to make a decision, we have an activation function, or we call the transfer function. So we have defined quite a number of activation functions, out of which actually it gives the output. So here, this is activation function. So it depends upon the function definition. One of the function is very popular, which we call the sigmoid function. So sigmoid function at the end will give the output. So when we have these similar values, put again, the weightage change again, and if the sigma output is becoming similar again, that means the network already learned the system. That means similar stuff with minor differences. Now you put it again here, you will find the similar output. So once we have learned with a few of the inputs, the learning is successful, then similar things, if you put as an input, you can have the output. So that is basically we work. Specifically when you have the classification, say in a machine, you want to separate, say, in a fruit factory, they are separating bananas and pears. So you have a neural network system. The neural network already learned to differentiate banana and pear. So when you pass any banana, as long as it is a banana, size and shape doesn't make much difference. Similar is the pear. So it is not template matching, because there were system last time we used to call template matching. Template matching is basically when we have the image, we have to match pixel by pixel. So that was very difficult actually to apply the system. But this kind of system is very powerful in that sense. Okay, so this is the activation function, and you have the output. And once the learning is done, then your task is already done. So the neural network, you can just transfer to your machine, and you give this similar input, because when you have a neural network, basically the training is specific to particular area or particular set of classification. It cannot be so universal. So we have the static neural network and dynamic neural network. As I said, this is a training process. So how good is the training? Okay. So how good is the training? So basically, when you are training, so you have the input known, you have the output known. So when you are training, if the input doesn't give the corresponding output, so there will be some error. So error, you give the feedback. So it recalculates the weights, and that's the way the new weights come. So it is kind of regression analysis, but in a different way. And the mathematics is not that simple. Mathematics is quite complex. And that is why if you want to implement the neural network or even fuzzy logic, generally it is not wise to make all these calculations yourself. So you have to use the toolboxes. So MATLAB has got all these toolboxes, and now we have the Python. Python has got the toolboxes, but we need to know the way we have to work, how to set the inputs, and what kind of, sometimes you have the choice, what kind of activation function you need to use, because in some of the areas, some kind of activation functions work quite well. In some others, the activation functions doesn't work that well. Okay, so I already mentioned this learning process, supervised and unsupervised, as I mentioned. I already mentioned the supervised learning and unsupervised learning. Okay, now say I just mentioned, so some of the application: pattern recognition, signal processing, control system, system identification, classification, say thumb, so fingerprint detection. So what fingerprint detection does, if you to find any fingerprint detection system, now you have it in your smartphone. So in the smartphone will ask you to press the finger few times. So it is actually, once it gets this fingerprint, then it actually put in its neural network. If the neural network will give an output, then you put it again, it will calculate it again back. Unless all these actually matches from the same finger, it will be asking you again and again. Once the match is quite proper, then it's okay, they're done. Then thereafter, from one to whatever orientation, you see, you gave maybe 4 or 5 orientations, the finger. But in real life, you are not making 4 or 5 orientation. You are maybe making 1,000 orientations. But still the system can recognize your finger. So it basically takes the statistical information. So for fingerprint experts, so here comes the expert system. Fingerprint experts, they have some elements actually in the fingers. They call the looping and some segmentation. So those are actually given as taken out of the system, and that is actually the training for the network. And here are the complex networks, how they generate what is called the weightage. And sometimes we have the intermediate layers, we call the hidden layers. Hidden layers can be theoretically as many layers as possible. It can be, but so far practically it has been seen the 2 is quite satisfactory. In most of the cases, the 2 hidden layers actually works. In that case, you have the additional weights. So here they are declaring the V is one set of weight and W is another set of weight. And we have those calculations and how they are making calculations. And this is basically the sigmoid function, as I mentioned, the activation function. This is a very popular activation function. It works very well. Okay, so there are other mathematics, so I'm not going. So here you can see that we are checking the error of the output and error in the training. So while we are training, so the errors we calculate and we feedback the error to recalculate the weights so that we can have a better training. And to make the process faster, sometimes we need to go for the optimization techniques we have to apply. So here we can see the error surface. It is just a tool. This is for the sake of understanding, they just put a what do you call 2-dimensional surface. So what is the error? To minimize the error, so we have the error distribution, and out of the error distribution, you have to, so this is the point of minimum error. If you go back to your calculus, basically how to find it, so you have to find this location using the differentiation. So you have to differentiate along the x direction, along the y direction. In this case, basically w direction and the v direction. So you have the differentiation in the w direction, v direction. So that is the way you actually calculate, and you minimize to identify the location at what v and what w this error is minimum, because we cannot make exactly 0 error. And these are, as I mentioned, the difficult calculations coming here. So all these are calculations. So that is why it is very difficult to.
Sir, there are questions in the chat box.
Okay, because let me finish it first because it's almost at the end.
Okay.
Okay, so there are examples of usage. So you have the handwriting detection. You can have the training. So you write a 5 in different ways. You train it so it can recognize your handwriting. So whenever you write 5 again, so it can identify. So this is the way. So now you know our screen sensitive devices. They have these systems available. So you can have the handwriting to text conversion. And ANFIS is another technique specifically used in case of the control system, artificial neural network and fuzzy inference system. As I say, the fuzzy inference system requires the fuzzy rules of the expert system. Sometimes the expert systems are not available. In that case, what we do, we actually use the artificial neural network to develop that expert system, and then that is we use as a fuzzy rule base, and that's the way we make it work, and that works quite better. And in case of the robotic motion, robotic arms, and whatever, we use actually this image classification, so many things. Okay, this is something different. I will show later. Okay, so we have the questions. Let me check. Oh, so update the weights by what technique? I think I have shown the mathematics. There are the mathematics available. Okay, so those are the mathematics they actually use. And there are simplistic approaches and there are complex approaches. So those are the ways. These are kind of recursive techniques. So once you have it and the error is that it takes the error, I think if you go back. You can see the error calculations.
Yes, sir, we can see that.
Yeah, so these are, so we have to, everything is available. Yes. Things are from the book. You can see the equation numbers are there. So these are not research stuff. If you go to the artificial intelligence books, you can find this. Okay, here just I'm showing some interesting stuff. I was supposed to also present genetic algorithms, so I cannot cover actually. So we use a genetic algorithm basically to develop our snake robot. So see, so how to control the shape and how to minimize the energy and increase the distances. So those were the conditions. So genetic algorithm is basically used for optimizations. So you can see this is the snake robot actually we developed, and it was optimized using the genetic algorithms. Genetic algorithm basically is an optimization technique. And there are a lot of optimization techniques, and genetic algorithm is popular for one of the reasons, because it used these initial conditions unbiased. So it doesn't get stuck in what is called the concave region of the what is called universe. Okay, and for what is called an industrial robot, we actually did a research where actually we used some navigation algorithm to you can see here this is a, so here we have to use the statistical inferences to avoid collision between a robot and a running object. So an object is moving towards it, and the robot can detect it has a camera at the tip of the robot, and it replans its trajectory to avoid the collision between the object moving towards this. So here you can see the algorithm is here, but when you do the implementation, the algorithms basically we use in the ROS platform, robotic operating system. So robotic operating system is basically used for the robot design nowadays, which is getting very popular. Okay. So in conclusion, we can see smart, affordable, and sustainable products needs multidisciplinary knowledge, AI-based decision, IoT, and IR4. And we need to learn AI to adapt to the new technologies. Okay, so thank you.
For students, if you have any queries, please feel free to ask directly or put your question in the chat box. Sir will be happy to answer your question.
Okay. The question is, what types of skills do we need as a mechanical engineer to become compatible with AI? Okay, so basically, what is the problem with the traditional mechanical engineers? I'm a mechanical engineer as well, but because I'm working with mechatronics, so many things I have to learn myself. So you must be self-learner. This is one of the things. And nowadays, if you have interest to learn, materials are available. Okay. I didn't have it. The first you can start, just you Google. You want to learn something, there are tutorials, the basic things you can. If you want to learn better and advanced, there are online courses you can register. So this is the way. So for this area specifically, if we look at this smart generation, they are learning themselves from the internet and the knowledgeable people rather than from the schools. Schools, yeah, of course, we have mechatronics engineering. So under mechatronics engineering, we have a course in the, what do you call, core course. It's not elective, which is on computational intelligence. So computational intelligence, basically, we teach them this basic intelligence system. So artificial neural network, fuzzy logic, genetic algorithm like this. But this convolution neural network, which are the advanced topic nowadays, so we don't teach under the core. Those are, in our case, we have in the elective courses. We have a stream of artificial intelligence where it is. But for those are in Bangladesh, I would suggest if you have the interest, you go to the internet. There are books available. There are free tutorials available, so you can have the initial part. And once you can identify who is the lecturer in your university or around, you can just consult time to time. I think that will help you to learn it. And we need to learn it. Maybe the mechanical engineering will also come up with this kind of slot, but it will take time. It is not that easy to implement immediately because the traditional mechanical department, they don't have people with artificial intelligence background. If it is maybe very limited, we will be engaged with other tasks, not with this course.
Sir, there are similar type of questions.
Yeah.
Another, how can we start AI from the beginning as a mechanical engineering student?
As a mechanical engineering student, I think I already answered the first answer to the first question, and the second question is same. Because as a mechanical engineer, in your curriculum, you don't have similar course. And I'm not sure whether you have the course from elective. But if you have the option in your university to take course from electrical engineering, generally electrical engineering or computer science, they teach artificial intelligence. And if you have a scope of auditing the course, you can audit there. Maybe audit will charge you some money. But you still can go to the online, and there are a lot of items there. If you are interested, you can learn it. Learning nowadays is not constrained. You don't need to spend what is called a very big amount of money.
Okay,
Even the
sir.
very good schools are also offering these courses with reasonable pricing.
Sir, there are another question. MATLAB or Python, which one is more important for learning AI?
Okay, MATLAB is always good, but the MATLAB you need to buy, because the toolboxes, if you use the pirated, that you cannot use. For the learning purposes, for the students, they may use the pirated. For the lecturers, I cannot have a pirated MATLAB in my computer. In Malaysia, it is very strict. If I put a pirated software in my office computer, and if I am caught, the university will kick me out, and the company will sue me for million ringgit. For students, they don't mind. I would suggest go for Python. Python is becoming richer and richer, and it is open source. And there are open source modules also available from what is called for Python. So I would suggest go Python.
Okay, sir. Also, our Professor Mazhar sir shared some course and materials to all of our students. I think it will be very beneficial for all of us.
Okay, it's deep learning and machine learning is advanced. Prof. Mazhar, deep learning is higher than the learning I thought. Anyway, but they can start. The deep learning basically is a convolution neural network called the CNN. And basically all these mathematics in depth is not necessary for mechanical engineers. So that is why if you learn, then you use the platform. Say if you use the Python, then the Python has the modules, and also you can have the Python modules from open source platform for different authors. Those you can plug in, and you can actually plug and play with artificial intelligence.
Okay, sir, there is no more questions. I would like to thank you from the bottom of my heart for giving us your valuable time from your busy schedule. It is the most informative presentation I have ever seen about artificial intelligence. Definitely, it gives us an idea about the fuzzy inference system, artificial neural network, and overall AI technology. ASME AUST Student Chapter is really honored to have you as our guest. Thank you again, sir, for your amazing speech.
So thank you very much. I'll be very happy if at least 1 or 2 students get engaged in learning AI themselves.
Inshallah, sir. If anyone is interested, maybe he or she will contact with you or anything.
Now we have enough department. We have AI experts, good AI people we have.
Okay, sir. Thank you.
I borrowed many of the slides from them.
Okay, sir. Sir, it will be very beneficial if you provide us or I will collect you from the mail, and we will mail you if any student need.
Okay.
Thank you to our respected teachers and honorable guest, Professor Dr. Mazhar Islam sir, for giving us your valuable time. Also, we see that Dr. A.K. Ahmed Hassan sir also presented here. So thank you so much, sir. We are really honored for all of us to have in our seminar. Thank you everyone for being here today. I wish you all good evening. Thank you for taking the time to listen. Have a great day. Sir, I think we can conclude our presentation. Sir.
Yeah.
Okay, sir. So we think we can close our seminar. So,
okay, so
thank you, sir.
Okay, thank you very much. Thank you, everybody. Assalamu alaikum.
Assalamu alaikum, sir.